And now I'm going to find what is GM. So GM equal to I naught by VI. I naught by VI. And we have only one voltage here. Since you have a single loop, there's no difference between Vs and Vi. Everything is going to be Vs. So Gm is equal to I naught by Vi, which is I naught by Vs. And I naught, you know, it is minus IC. See, IC direction is not given. You can very well assume always the transistor currents will be flowing towards the terminal. Collector current will be flowing towards the terminal C. Base current will be flowing towards the terminal B. Emitter current will be flowing away from the terminal E. So that is the notation you have to follow. So I naught is minus IC and IC is going to be HFE IB. So GM is equal to minus HFE IB divided by Vs. This is one equation we have, minus HFE IB by Vs. Now I need to find what is Vs. So apply KVL in this loop. It's a very single loop, so it is very simple equation. I can write Vs equal to IB into Rs plus HIE plus RE. The same current IB is flowing through all the components. So I can write Vs equal to IB into Rs plus HIE plus RE. So substitute that here, IB and IB will get cancelled. So you get minus HFE divided by Rs plus HIE plus RE. So this is the example for, this is the expression for transconductance GM. The transconductance, whenever you write without that F, it is meaning without feedback. So when you want to find what is the transconductance with feedback, you have to find what is D. D is called as D sensitivity. B is given by 1 plus beta into GM. See, here we get 1 plus beta into GM. If the amplifier is an voltage amplifier, you get 1 plus beta into AV. If it is current amplifier, you will get 1 plus beta into AI. If it is trans resistance amplifier, you get 1 plus beta into RM. So here, generalized formula, we write D is equal to 1 plus beta A. That A can be voltage gain, current gain, trans conductance or trans resistance. So 1 plus beta into GM. So GM is expression we have derived and beta is minus RE. So substitute everything, take LCM and have it as a fraction. So this is going to be your D sensitivity. Now for finding out GMF equal to GM by D. So divide the GM expression we have, D expression we have, divide both, you get minus HFE divided by RS plus HIE plus 1 plus HFE into RE. So when you consider these two terms, when the denominator, when you consider RS plus HIE and this term, this 1 plus HFE into RE is very, very large because HFE is the beta value answer and it will be very, very large. So I can neglect this term RS plus HIE. So I can write GM is approximately equal to minus HFE by 1 plus HFE into RE. HFE by 1 plus HFE is almost going to be approximately 1. So this minus HFE and 1 by 1 plus HFE, I can take them to be equal. So approximately I get GMF equal to minus 1 by RE. And RE is going to be beta. So we have seen that in the basic feedback, the gain is inversely proportional to beta. So that is obeyed here. See, this is not possible from the exact expression for GMF. We are applying some approximation to check whether the value of GMF is inversely proportional to your beta. So if RE is a stable resistor, then your GM depends on RE. So more the value of RE, lesser is going to be the value of the transconductance of the amplifier. Okay. So this is going to be the transconductance. And also you see the load current is given by I naught equal to GMF into Vs. GMF expression, you know, minus HFE Vs divided by Rs plus HIE plus 1 plus HFE into RE. It is approximately minus Rs by minus Vs by RE. See, you can easily relate the output current in terms of the input voltage and the feedback resistance RE. So the output current depends only on RE because Vs is going to be constant. So the output current depends only on the feedback resistance RE. So RE plays a very, very crucial role in providing proper negative feedback to the amplifier. So what value of RE you're going to take is going to decide the performance of your circuit completely. Okay, so you have to be very, very careful in designing what value of RE we are going to choose for this current series feedback amplifier.